So has anyone managed to answer this question? All right, okay. Yes, good. Well, you know, that's not bad. That's not bad, because this is indeed the Hodge conjecture in algebraic geometry, and if you could answer this in the positive or the negative, you would be awarded $1 million. And I put it up there for a serious reason, not just to challenge you, but to sort of illustrate what most people think fundamentally intelligence consists in, that somehow this kind of reasoning is what is meant by extraordinary intellectual capability, and what I'm trying to convince you in this talk is that that's nonsense. Because what this is an example of is what this cartoon I'm going to show you now illustrates so well. Right. So everyone can see this? Got it? So we have a range of animals, they're being examined, and the examination is climbing a tree. And of course you all know that there's only one or two animals in that lineup that would be likely to fulfill the requirement. And that is essentially the challenge of intelligence. When you operationalize it to the extent that you can instrumentalize it and measure it, you've immediately committed yourself to an interpretation of what it is. And there's nothing wrong with that, because we do that in science all the time, but the mistake that is made is to equate the measurement with the thing itself. Right? It's a correlate of the thing, it reveals elements of the thing, but it isn't it. And if you ask questions, you're very likely to limit the range of phenomena that we might like to think of as intelligent. And so the history of intelligence research has been, on the one hand, fairly noble attempts to quantify research, the phenomenon, but also extraordinarily stupid. So this is an example of some early attempts to quantify and measure intelligence through comparison. And I'm not joking when I say that this was a very popular book. I imagine people walking around the streets looking to see whether or not you resembled a pig or a horse to determine your general IQ level. So that's part of the history, but it only gets worse. And so these are machines that we use to quantify intelligence. These are essentially early fMRI machines. That's what we're looking at here, about as intelligent as fMRI machines. On the left, the craniometer, and on the right, the Lavery Electric Automatic Phronometer. That was released in 1907, and this one is the portable edition. And you could take it home, you'd give it to your kids for Christmas, and humiliate them for the rest of their lives. It measures bumps on the skull. The premise is that those bumps somehow reveal fundamental cognitive capabilities. This is where it moved to. This is a famous IQ test. This is the Yerkes Alpha. Robert Yerkes was a psychologist at Harvard, and he became very interested in the war effort. He wanted to make the American Psychological Association relevant for the nation. And so he volunteered to establish exams to test soldiers. The alpha was a textual exam. The beta was visual, because it was for people who were illiterate. And the gamma was for people, in his words, who were hopeless. And I'm not sure if you can actually read this. Can anyone actually see? The questions are extraordinarily interesting. On the left, they've been answered correctly. But I need to put my glasses on for this myself. So the kinds of questions you were asked, some of my favorites. Why is beef better food than cabbage? Because A, it tastes better, B, it is more nourishing, or C, it is harder to obtain. Right? Don't get that one wrong. This was, if you do not get a letter from home, so this is for a soldier, which you know was written, it may be because A, it was lost in the mail, B, you forgot to tell your people to write, and C, the postal service has been discontinued. And so those were answered correctly. And on the right, there are some like, why are criminals locked up? A, to protect society. B, to get even with them, which we know is the true answer. And C, to make them work, and so on. And so this is the history of intelligence testing in this country. And so it's extraordinary how stupid we've been about intelligence. So in a way, one way to sort of pass this landscape is into four basic schools. There's the school that's fundamentally interested in what we think of as human symbolic intelligence. So for many people, you can't really talk to them about non-human, because you can't talk about intelligence if you're not talking about language. That's the first stupidity. Another one is the animal comparative perspective. Well, actually, no, it's actually a widespread feature. The particular form it takes in us is symbolic, but there are analogous mechanisms present in the rest of animate nature. Another that you will find in ethnography and archaeology is cultural and collective. Cities, for example, great Roman cities, Mayan cities are evidence of intelligence above and beyond individual capability. And finally, the technological computational, which seems to obsess us today, where we're essentially interested in engineering systems that manifest intelligence. And these four perspectives have led to all sorts of interesting conflicts. So one way of classifying these schools is by bisecting them into those who believe essentially that only biological phenomena can be intelligent, and those who believe that technological phenomena and even social phenomena can be intelligent. So a city, for example, might be in some sense, some measurable sense, intelligent. So for example, an example of a biological naturalist would be John Searle. So here he says, my car and my adding machine understand nothing. They are not in that line of business. They're machines. They might perform computations just like DeepMind, but they don't understand anything. And contrast that to the most famous functionalist of all, Alan Turing, who said, we're not interested in the fact that the brain has the consistency of cold porridge. Wait, I don't care what it's made of. I care what the input-output function is. You can slice it up another way into purely human phenomena. Right? So you'd accept that individual, symbolic, reasoning human beings are smart, but so can humans in the aggregate. What isn't is anything non-human, which would include animals and would include technology. And there you find anthropocentrism on one hand, or let's call it infocentrism on the other. And here we have Chomsky, for example, who for most of his career until relatively recently argued that intelligence has a material basis in his world language, and that is an organ of language, and that organ is unique to our lineage, in the same way that echolocation might be unique to, say, bats and dolphins. So there's nothing we can do about it because we don't possess the organ. In contrast to Darwin, who said there's nothing unique to any animal because it contradicts the fundamental tenet of evolutionary theory, that is continuous variation. Natura non saltus, right? There is no discontinuity in the natural world. There's always something homologous to it if you look hard enough. And the idea of this meeting is to somewhat transcend those schools of thought and ask how ideas from each might diffuse. And what are the benefits of thinking about naturalism from a functionalist perspective? Now, there have been people who have tried to overcome the limits of instrumentalism. So in other words, if I have a quantitative means of measuring intelligence, and I assign, and I claim that that is intelligence, there's something limiting there. Is there a more general principle? And there have been many people who have tried to define intelligence generally, and I'll give you some very famous examples. This one is from Binet. Binet was one of the creators of the IQ test. Another creator of another IQ test. And most recently, Gene Symington's definition. So if I asked anyone in this room, what are you thinking of when you see those definitions, you would say, evolution by natural selection. They've just talked about evolution by natural selection. Is that the same as intelligence? Well, maybe. Maybe. I'm going to argue that there's a much more useful definition of intelligence, and that's mine, and that actually has the value of being instrumental and general. And some of you, or many of you, have heard this before. So what is intelligence? And you all know it because, and I give you this little case study, when you were at school and you were given a hard problem and you solved it effortlessly, the person sitting next to you said, "You're so smart. You made that hard problem look so easy." That is intelligence. Intelligence is making hard problems easy. And we'll get into how you do that and how that works in a second. But if intelligence is about making hard problems easy, what would you call making easy problems hard? you'd call it stupidity. And it's so interesting to me that we have so much emphasis on the analysis of intelligent systems and so little on the analysis of stupidity. And my theory for that is that academics are so vain that if one of our very generous trustees were to endow a chair in stupidity, they wouldn't accept it. I mean, it couldn't be the David Krakauer Professor of Stupidity. Even though, in a very real sense, in the world today, we know which the greater threat is. So, for example, what does this mean? Well, these are intelligent designs. If you're interested in the function we call flight, well, this is how you might accomplish that goal. And these are stupid designs. In other words, you'd be better off not going anywhere near these devices if you wanted to achieve liftoff. And you can demonstrate this with a simple IQ test, which I'm going to give you now. I push you off a building, and you wish to survive. You're not feeling suicidal. Do you choose A, to just be pushed off the building by me, B, sit in that device, a sort of steam locomotive underneath an inverted teacup, or C, I'd give you some helium-filled balloons and some rope. Which would you pick? C! Come on, guys. It's okay. I'm not holding this against you. I don't remember you. C, it's C. But if I gave you A and B, which would you pick then? Well, I'd pick A. I don't want to be in B. I don't want to be mangled by that device. There's a chance the wind might blow me through a window. It's not going to happen if I'm in that thing. And so this is the example. So there is truly worse than random performance when it comes to being pushed off a building. So let me give you some more serious examples, and it'll illustrate a very critical concept when we're talking about intelligent, which is the need for nulls. You can't just study a system and measure things and say it's intelligent. It's meaningless. You have to establish the counterfactual, so either random or worse than random behavior. So let me give you an example of how this works. So everyone is familiar with the idea of sorting a list. So I give you a list of numbers, and you sort it from low to high. Well, there are many algorithms to accomplish this. The random one is just to randomly move things about. And that scales in time, the time it takes to solve that, more or less n factorial. It takes an awful long time to sort things randomly. But you can use one of these algorithms like bubble sort, and bubble sort scales quadratically. Goes as the input set raised to the power 2. But you can be better than that and use something like quicksort, and that scales n log n. And I've plotted these, if you can see them on the right. And so on the top right, that's the yellow curve is the factorial, the time complexity of scaling. The blue is the quadratic, and the green is the n log n. And you can see that as you increase the size of the set, very quickly, the factorial one becomes untenable. It's essentially infinite time with anything sizable. On the other hand, if you were to exclude that, you can see that the n log n does significantly better than the n squared. So these give us a set of references against which to compare performance. Right? So we have near random performance, which is terrible. And in this case, there's nothing worse than random. There's nothing stupid. A stupid case in sorting a list would be to take the number at the end of the list and just jiggle it with a number next to it forever. That's worse than random, right? So let's look at some real-life examples of stupidity and intelligence. Financial trading. So this is a paper that was published by one of our colleagues. He's at the ETH in Zurich. And they looked at 4 different financial indices. This is the FTSE UK. They also looked at the Bourse. They looked at the DAX. They looked at the S&P 500. And there it is, jiggering about. And they said, let's imagine the following challenge. I'm going to give you the performance of the index up to some point t, and you have to tell me whether the index will go up or go down in the next time step. That's it. That's success, getting that right. And you're going to do it randomly with a uniform prior, probability of a half going up, a half going down, or you're going to use an algorithm. And there are a whole number of different algorithms. You can use a momentum algorithm that uses the recent past. You can use a variety of exponentially weighted averages. which they did. And what did they find? They found that in most cases, the random decision as to whether the market would be bullish or bearish outperformed the algorithm. And when they looked at the variation in performance, the random algorithm was vastly better, right, than the momentum-based or memory-based or autocorrelation-based algorithms. So in a very real sense, these trading algorithms are stupid because their performance is considerably worse than chance. Something to bear in mind. And certainly in the long term, everyone in this room knows that given sufficient time, you will perform at chance. Here's another example. Oh yes, that's the measurement of stupidity, which is the variation in the expectation under the random model and the algorithmic model, and the variation in the variance. So let me give you another example that's of great concern to travelers, not to all of our trustees who have their own aircraft, but to people like me, which is how should you board an aircraft? And there are different styles of boarding. You can board the first 10 seats and then the next 10 seats. You can do rotation boarding. You can board from the window to the aisle. And we've all had to suffer the ignominy of one or other of these boarding strategies at some point in our lives before we had our own planes. Or you can board the plane randomly. So put people in first class first and then randomly. And what do you find? What do you think you find? You know the answer to this because I wouldn't be showing it to you. They're all stupid. The random boarding strategy outperforms all of those boarding strategies. And yet we go to airports, we wait with our little numbers, and board the plane according to the algorithm. Why did people adopt them? Well, you tell me. So culture is full of worse than chance algorithms. And so it's not just individuals who behave stupidly, we behave incredibly stupidly as a collective. So just sort of coming to the end here, one way then to think about the complexity of intelligence is in terms of these successful or unsuccessful algorithms that we find in nature, used by animals, by swarms, by us, but also in technology, mediated by software, for example, markets, market trading. And so when you think about it in these terms, it's perfectly permissible to refer to a market as stupid, or a trading algorithm as stupid, or an individual is stupid, or an individual is smart, because we have a baseline against which to measure the improvement of performance. And of course, over the last several years, we've realized that it's not only humans that have these extraordinary natural algorithms for solving problems that do significantly better than chance. And so the boundaries between the human species and the non-human species have been gradually chipped away. But also the boundaries between humans and machines. And various people will be talking about this today. And the way we deal with this, of course, is to claim that this is not legitimate, because we resort to a form of biological naturalism or biocentrism, and claim this isn't intelligence, this is something else for which we don't yet have a name. But if you accept my operational definition, then you have to grant that all of these systems are manifesting both intelligence and stupidity. So I'm sort of trying to summarize what I think the true history of this topic has been. And I think this is the fundamental problem. I just sort of distill it into the most coarse-grained conclusion. It's that we overestimate individual human analytical intelligence. That has been, to my mind, the very worst thing that we've been doing historically. And contrariwise, underestimating organic and cultural evolution producing collective intelligence. And one way to think about the Santa Fe Institute is the institute that worries about that. So many of you have read the books, you've read about swarms, you've read about bottom-up systems. In a way, that's what we're saying. We're saying that we have to pay more attention to collectives and how they solve problems. They might be collections of cells or collectives of individuals, but apportion slightly less importance or much less importance to the myth of the great genius like a Newton or a Leibniz or an Einstein, which is the canonical model of intelligence, which, as far as I'm concerned, has held the world back. And with that, I will now turn it over to someone who will talk with authority about collective intelligence.